Today, boys and girls, children of all ages, we discuss probability. And unfortunately, probability gets split into two categories in this lesson, and it is the independent probability and the dependent, all E's, and dependent. All E's as well, is that right? Who's my spellers? Oh, that's like a full pop. I wonder if that'll be extra credit today on the spelling test. Probably. What's the difference between being dependent and independent, John Murray? I know you know the answer, so don't be afraid to shout it out at any time. What's independent? How is independent different than dependent? Without looking in the book, I can tell you. Was it better for you to be an independent person or a dependent person? If you look at being independent as a compliment or is that a put down? On your taxes, by the way, your parents claim you as dependents. If that makes any sense to you. Fisher, help me out here. Work with me.
Dependent means you're relying on some things, and independent means you don't.
Right. Independent means you stand alone. Okay. So when we talk about probability, we're talking about probability of like multiple events. Multiples. If it's independent, it means that one event does not affect the other. I always get effect or affect. Is that great? A or E?
I have the worst spelling.
No, I'm talking about the use of the word. E, affect as an E or affect as an A? Wait, somebody's overruling me? A or E? Who knows that for sure? I'll go with Aaron. Does affect. You know how I know that's right? Because it says it right there in the book. Were you looking at the book? And the other one, dependent, means that one does not affect the other. What does this mean, you ask?
What does this mean?
Well, usually when the book presents this, I believe they talk about well, here, let's look at this. Let's say you have a subtenor that's split into A, B, and C, and D, and you are flipping a coin. Make it a penny. And I asked you to find the probability of spinning an A and getting a head. Does, the question you ask yourself, does spinning this spinner change anything at all about flipping a head? Not at all. Okay, the outcome, I could spin this a zillion times, it's not going to change any difference there. And if that is the case, you just take this. To find the answer to the problem, you take the probability of getting an A and you multiply it by the probability of getting the second event, which is the heads or the tails, the head side. And what is the probability of spinning an A on that little wheel? 1/4. And what is the probability of flipping a head? What is the probability of both of those happening? 1/8. Okay. Probability of independent events. They don't affect the others. Now, the other one, dependent, would be this. Let's say you've got a bag. Let's say it's a brown paper bag, or in this case, a red outline bag. And in that bag you have, put some dash lines here. In that bag you have 4 green marbles, which nobody can see, and 2 blue marbles. and I asked you the probability of pulling out both blue marbles, and here's the key, without putting one back when you draw it. It is still, the probability is still going to be the probability of getting a blue marble times the probability of getting a blue marble. But the probabilities change because when you take the blue marble out, there's not as many marbles, both blue and total, in there. So that one is dependent on the other. The probability of pulling a blue marble would be 2 out of 6 for the first one. Now you don't have 2 blue marbles in there. Through the magic of the board, Mr. Blue Marble is coming out. On my second draw, I only have 1 blue marble out, and I only have 5 total marbles in there. So it depends on what you did in that first one. So this is dependent. If you do the math on this, what is it? I don't know, it's 3 over 30, or 2 over 30, which is 1/5. So that is the dependent end of things. Did we do this last year? Then why do we keep doing this? Let's look. Take a look. Let's look at a couple examples just to get your to wet, W-H-E-T, your whistle. It is, by the way, W-H-E-T, isn't it? No, wait. Wet your whistle with W-E-T. What's W-H-E-T?
I have no idea.
Look that up, by the way. That might come up on spelling too.
Okay, what's that?
Page 208. What's that? Wet, W-H-E-T.
Huh?
Oh, Jesus wept? No. I don't think Jesus wept anything. I said wet, W-H-E-T. Wet.
No. Is that even a word? Yeah.
Boy, Madison, I don't know. Take a look at page 208, everybody. The directions say identify this as independent or dependent. Do they stand alone, or does what happens in the first thing change the probability of the second thing? Letter A says if you choose a card from a deck of cards, replace it, and then a second card is chosen. Is that dependent or independent? Oh boy, suddenly we're at a standstill. Chase is going out on a limb and saying it is not dependent. Why is it not dependent? Because you put the card back. Okay. The probability of the second one will not be changed by the first one if you put the card back. Just like if I would have drawn this blue marble and then put the blue marble back in, these would both be 2/6 times 2/6, so the probability wouldn't change. It's only dependent if you take it out and it changes the second thing. Good, so far so good. We are learning quickly. Letter B. What about a marble drawn from a bag, kept, and then a second marble is drawn? That's too brute, Emma Miller? It is dependent, because if you keep that marble, it's going to change. Keeping that marble changes everything from there on. Letter C. A coin is flipped, and then a number cube is rolled. Are those dependent on each other, or are they completely independent, John Murray?
Independent.
Yeah. Flipping a coin is having nothing to do with the flipping, the rolling the die. Letter D, a spinner is spun and the result is recorded. Then the spinner is spun a second time. Dependent, independent. Andrew? It is independent, because spinning the first one will never change the second one. Unless you could take part of the wheel off. Then you'd be trouble. Letter E, a coin is flipped and a 6-sided number cube is tossed. Make a tree diagram showing all possible outcomes. What in the world is that? What's the probability of landing on a tail? Do we have to do that tree diagram, or can we just hunt? Who says they need a tree diagram? Oh, now you're just lying, most of you. That just means this. You're flipping a coin. You've got two events. You've got the coin flip, and then you've got what? The dice? Die, right?
Yeah.
So if you flip a coin, you can either get a head or a tail, and the reason this is called a tree diagram is because off of that, what are your possibilities with the die? Well, you get a 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Or you get a 1, 2, 3, 4, 5, 6. Uh-oh. And then if you're writing down your sample space, you have to write down head 1, head 2, head 3, head 4, head 5, head 6, tail 1, tail 2, tail 3, tail 4, tail 5, tail 6, and that would be it. And then you find the probability. What's the probability of landing on tails and on an even number? So how many tails, even numbers, would there be? Tail 2, tail 4, tail 6. There's 3 tail even numbers out of how many total combinations?
12.
12. Which is 1/4. What is the probability that anybody understands that? Would that be independent or dependent? Letter F. Find the probability of drawing a red block, keeping it, and then drawing another block. Is that dependent or independent? Everybody, all together.
Dependent.
I noticed somebody not saying something. Joseph, dependent or independent?
Dependent.
It is dependent. What about G? Find the probability of drawing a blue block, keeping it, and then drawing a red block. Dependent or independent?
Dependent.
Look at you. Very good. Ooh, have we talked odds this year?
No.
Write this down, blank piece of paper, just so you have it. Odds are you'll like this.
Nice one.
Odds are very similar to probability, except in the fact that odds are, it's the ratio of favorable to unfavorable. Usually when we do odds, we do it like this. Favorable to unfavorable. Was that somebody in here yesterday that put the time down for my ratio? Was that you, Chris? Yeah. That's usually, whereas probability is favorable to total outcomes, favorable to unfavorable is odds. For example, looking in the book, what are the odds of spinning black? If you're looking in the book on that odds of spinning black, how many, the favorable is how many black pieces are there? Look in the book. Tell me, how many? 2. How many not black wedges are there?
6.
Is it right cut just into 8 pieces? 2 is 6. Now the question is, do you reduce that? Absolutely. 1 to 3 is your odds. Your odds are 1, 2, 3. Yes.
If we didn't produce it, would we get it wrong?
Absolutely. Why not? Is that it? Is game over? Oh, game over.